In the middle of twilight grasslands, a giraffe stands motionless for just 4 minutes, eyes half closed, then suddenly wakes up. And that's the only sleep session for the next 6 hours. This shouldn't be possible. Humans collapse after 24 hours without sleep. Most mammals need 6 to 12 hours of sleep per day. Your brain needs REM sleep to repair itself, save your memories, to survive. But the giraffe operates on 30 minutes of sleep total. Dr. Mads Bertelsen from Copenhagen Zoo describes this as the most extreme sleep deprivation strategy in nature. Elephants sleep 3 to 4 hours, lions rest 12-14 hours, but the giraffe, just 30 minutes. Right now you're watching the giraffe's sleep position on screen. Long neck curled, head resting on its legs, completely defenseless. Tonight, we'll discover how the giraffe survives with this extreme sleep strategy and why it rarely chooses to lie down. If this 30-minute sleep strategy fascinates you as much as it does me, hit like and subscribe. Write in the comments where you're watching from, what time it is there, and what surprises you most about giraffes. You're the reason we keep discovering nature's secrets. Thank you for being here. First, let's note that researchers don't fully agree on the findings we'll be discussing. Some information is not definitive. Now let's take a closer look at how the giraffe survives on just 30 minutes of sleep. The giraffe stands in an open area beneath acacia trees. It closes its eyes for 4 minutes, motionless, head tilted slightly forward. During this time, the world keeps spinning around it. In the distance, a lion's roar echoes across the savanna. The giraffe's ears twitch, its eyes open, the micro-sleep ends. These brief sleep moments repeat throughout the night. They add up to just 30 minutes of sleep per night. Think about your own sleep for a moment. When you sleep even 2 hours less, you feel it immediately. Concentration drops, your mood changes. Now imagine living your entire life on rest that doesn't even last as long as a lunch break. This is the reality the giraffe lives every single day. Total sleep time is spread across 24 hours, 30 minutes total. This doesn't happen all at once, but in short intervals of a few minutes. 4 minutes here, 2 minutes there. They never sleep longer than 5 minutes at a time in the wild. Most of the time they shift positions to stay standing, resting by curling their head and neck backward and leaning them against their hindquarters. We've studied sleep in hundreds of mammal species. Every animal needs rest. The pattern is consistent. Scientists first documented this pattern in zoos where observation is easier. Because there's no predator threat in the zoo, giraffes sleep more. A study of 8 giraffes showed they slept an average of about 4 hours per day. When there are no predators nearby, giraffes are more often seen lying on the ground with their legs tucked underneath them. Animals in controlled settings are comfortable enough to actually lie down. In the African savanna, where lions hunt and hyenas patrol, 30 minutes becomes standard, sometimes even less. Field observations tracked individual giraffes across multiple nights and found biologically unusual sleep patterns. One giraffe was documented going 72 hours on only scattered 5-minute naps. You might wonder how this works. How does a brain function without rest? Where does the giraffe find the energy to stay alert when predators approach? The answer lies not in how much they sleep, but in how they sleep. Standing rest makes up most of the giraffe's sleep time. The animal stands upright, legs locked, neck slightly curved. Eyes remain partially open, ears keep twitching at every sound. We do something similar when we doze off on a train. You sleep, but part of your brain stays online and monitors for threats. For the giraffe, this becomes the primary sleep mode. Most of the time they rest standing and again in short bursts of half sleep. Their eyes stay half open and they remain upright. This is different from sleeping. The animal spends hours in this semi-awake state. Standing naps are the safest way for giraffes to rest because getting up from the ground takes time, and if there's a predator nearby, that time is critical. Then there's REM sleep, the stage where dreams happen. During this phase, memory strengthens and the nervous system rests. In giraffes, REM sleep requires lying down because muscles relax during this time and the body can't support its own weight. When a giraffe enters REM sleep, it folds its long legs under its body and lowers itself to the ground. Then the neck curves backward and the head rests on the animal's own hindquarters. When they're young, they sleep the same way, but the position becomes harder to catch. They basically become their own pillow. It looks uncomfortable to us, but when your neck is nearly 2 meters long, it's the only position that works. But there's a problem. In giraffes, REM phases last at most 2 to 4 minutes. Throughout the night, when a giraffe truly sleeps in short bursts for 30 minutes total, it's in REM sleep. This is the total time spread across the entire night. Let's compare with our own sleep. Every night you spend about 2 hours in REM sleep. The giraffe, if it's lucky, spends 30 minutes. So why so little? Because lying down is dangerous. A giraffe is lying on the ground in the darkness. If there's a predator nearby, when it notices the danger, it only has a few seconds to react. Standing up is not a quick movement for giraffes. First, they need to unfold their legs, shift their weight forward, and then bring themselves to an upright position. This process takes about 8 to 10 seconds. For an animal that can't muster a defense, this time creates a disadvantage against an approaching predator, but sleeping standing offers an escape route. Giraffes are very large, and when they wake up, they can run up to 35 miles per hour. So when they're awake, they're not easy targets. Lying down eliminates this option. That's why they minimize it. They take their REM sleep in tiny doses scattered throughout the night, never long enough to enter a state of deep unconsciousness, never long enough to miss warning sign. We've observed something fascinating about these REM phases. They don't happen randomly. Giraffes enter deeper sleep during specific time windows, usually right after sunset and again before sunrise. Their 24-hour sleep pattern looks like this. Between 8 p.m. and 7 a.m. there are brief main sleep periods. Between noon and 4 p.m. they also take a few short naps. These are the times when wild giraffes take the risk of lying down. When giraffes enter REM, they lose the ability to hold their own heads and curl up to use their own hindquarters as a pillow. They rest their heads on their backs. In this state, the animal becomes truly defenseless. For these 2 to 4 minutes, the giraffe truly sleeps, and yet somehow this is enough. Researchers have tried to understand the mechanism. How does such limited REM sleep provide what the brain needs? Studies on sleep-deprived humans show rapid cognitive decline. After 72 hours without sleep, people hallucinate. But giraffes live their entire lives on a schedule that would count as serious sleep deprivation for humans, and they adapt to it. The leading theory involves sleep efficiency. Rapid eye movement sleep supports memory work, brain development, and emotional processing in mammals. Researchers sometimes record a distinctive sign: a soft curve of the neck, relaxed facial muscles, and small twitches around the eyes. Perhaps giraffe brains process information differently during these short REM periods. Maybe they fit more brain renewal into 4 minutes than we do in 40. We don't know yet. The answer stays hidden somewhere in these fragmented sleep cycles. What we do know is that stress affects this pattern. When giraffes experience a disruption, their already minimal sleep decreases even more. For example, when a giraffe is moved from one zoo to another or loses a mate, it sleeps even less than normal or doesn't sleep at all. In one documented case, a giraffe was shown to sleep only 11 minutes over 3 consecutive days. You can see the same thing in wild populations near human settlements. Giraffes living near villages sleep even less than those in remote areas. Constant disturbance keeps them in continuous light sleep. They never fully relax enough to take the risk of lying down. But the giraffe's biggest challenge isn't sleep, it's staying upright. Standing upright with such a long neck isn't just a matter of bone and muscle. The real problem is this: the heart has to overcome a 6-foot path to send blood to the brain. This is a battle against gravity, and the giraffe's body has gone through incredible changes to solve this. Chapter 2. The giraffe lifts its head from a puddle of water. The 6-foot neck straightens in 3 seconds. This sudden movement creates a serious balance shift for the body. For us, this would cause dizziness or lightheadedness. But the giraffe just pauses for a moment, blinks, and continues on its way. We need to understand what's happening inside this long neck, because what we're seeing is out of the ordinary. Giraffes have extremely high blood pressure because their heads are extremely high. Think about the physics here for a moment. Every centimeter of height increases pressure. The long vascular path between heart and brain makes it harder to carry blood upward. Your heart sits about 45 centimeters below your brain. The giraffe's heart sits about 2 meters below its brain. Sometimes, depending on how much the animal stretches its neck, this distance increases even more. The heart itself gives the first clue about how this is possible. We used to think giraffe hearts were massive. It made sense. Bigger animal, bigger heart, more pumping power. Although a giraffe's heart is bigger than many animals, it's about 0.6 meters long and weighs about 11 kilograms. For an animal weighing over 1,000 pounds, it's not as big as we'd expect. The left ventricle of the heart has to send blood all the way to the head along a long and vertical vessel. That's why the giraffe's heart works powerfully. It has thick muscle walls and its structure is designed to withstand high pressure. Think about your own heart. In the human heart, the left ventricle wall is about 1 to 1.5 centimeters thick, and that's enough to send blood through the body. In the giraffe, this wall is much thicker. Dense muscle tissue provides a powerful push with each beat. As the walls thicken, the inner chamber narrows. Less blood is carried, but this blood is delivered at higher pressure. In humans, chronic hypertension causes heart muscle to thicken. In this condition, muscle tissue hardens over time and loses its elasticity. The heart can't relax properly between beats. Blood backs up. The system collapses, but giraffe hearts don't harden. When Barbara Natterson, a cardiologist from Harvard, examined giraffe hearts with her student, she saw that the left ventricles were thickened, but there was no hardening or tissue degradation like what's seen in humans. The muscle stays flexible, strong but elastic, capable of producing extreme pressure but without degrading. The details of this process are still not fully understood. Researchers think giraffes have some genetic differences that prevent heart tissue from hardening. How it works isn't clear, but the result is the giraffe's heart can operate at high pressure for years without damage. But having a strong heart only solves half the problem. Getting blood up to the brain is one challenge. Preventing it from rushing back down is another challenge. When we stand up from a lying position, blood pressure in our brain drops momentarily. Your head might spin. Some people's vision goes dark. This comes from a temporary drop in blood flow while your circulatory system adjusts. Now imagine bending forward to touch your toes. Your head drops below your heart. Blood rushes to your brain. Pressure rises. You feel this as a slight fullness in your head. It's not dangerous, but it's noticeable. For the giraffe, this happens on a massive scale when they lower their heads to drink water. The direction of blood flowing along the neck changes rapidly. This time, blood pressure in the head rises to high levels. Then when they raise their heads again, pressure drops back to normal every single time, multiple times a day. So how do giraffes manage this? Part of the answer is hidden in the blood vessels of the neck. Along the neck vessels, one-way valves are placed every few centimeters. When the giraffe bends its neck down, these valves close and prevent excess blood from rushing to the head quickly. Blood gets trapped in the neck vessels and can't flow downward. The brain only gets what it needs, nothing more. Some blood just sits there in the neck, waiting. Then the giraffe lifts its head, the valves open. When the head goes back up, blood flows rapidly back from the vessels toward the heart, pressurizing the heart to pump blood back up from the neck to the brain. The stored blood provides instant support. But that's not all. At the base of the brain, there's a structure formed by small vessels that researchers call the wonder net. These vessels expand and contract to balance pressure changes. When pressure increases, they open a bit, and when it drops, they narrow to keep flow going. This is an extremely coordinated system, as if it was designed to be this way from the start. Now let's look at the legs. A 6-foot neck means the heart sits quite high off the ground, but the legs extend another 6 feet below that. Blood needs to travel 12 feet from the heart to the hooves, then it needs to go back up. Gravity constantly opposes this return journey. Blood wants to pool in the lower legs. This situation can lead to swelling in many animals. Fluid leaks from blood vessels into surrounding tissues. Ankles swell, legs ache, and over time sores can form. Giraffes stand 16 hours a day, sometimes 20 hours. Their legs should look like tree trunks from swelling, but they don't. The legs stay thin, they look almost delicate compared to body size. The secret is in the skin. Unlike humans, the skin on giraffes' legs doesn't expand. Dense and strong fibers with a thick outer layer create pressure within the tissue and make it harder for fluid to leak out. You can think of this like wrapping the leg with a tight bandage. The skin limits expansion. Giraffe skin basically does this. Giraffes reduce swelling with what's called the compression stocking method. The tight and dense connective tissue in their legs acts like a natural wrap. The pressure applied by the skin resists blood trying to seep into tissue. Fluid stays where it should be, inside the vessels. Researchers studied this with measurements. They saw that the giraffe's lower leg skin resisted much more pressure compared to neck skin. This showed that the tight tissue in the legs works like a natural wrap that makes it harder for fluid to seep into tissues. The difference was clear. Lower leg skin was about 3 times more resistant than neck skin. There's another mechanism at work here. Near the giraffe's knees, there are thick-walled vessels that can serve as flow restrictors. This can lower blood pressure in the lower legs, just like a kink in a garden hose lowers pressure after the kink. We don't know if giraffes can consciously control these valves. Can they tighten them when standing and open them when running? This question is still unanswered, but the structure exists, the capacity is there. All these systems work together. The thick-walled heart producing extreme pressure, the neck valves managing blood storage, the wonder net protecting the brain, the compression stocking-like skin protecting the legs. Each piece solves one aspect of an impossible problem, but there's still something we're trying to solve. It's not clear whether giraffes open and close vessels to regulate lower leg pressure as needed. When the giraffe is standing, this structure just below the knee is thought to regulate pressure by restricting flow, says Dr. Alkia from Aarhus University. But we don't know. The system works, we can see that. Giraffes thrive with it. But the exact mechanisms, the precise control systems, how all these pieces coordinate, we're still learning. No matter how complex these internal systems are, when you look from the outside, there's something that sets every giraffe apart from each other. The fur pattern. Just like fingerprints, no 2 giraffes have the same spots. And these patterns aren't just a beautiful coincidence, they play an important role in the giraffe's survival. Chapter 3. 6 feet of neck, a 25-pound heart, blood pressure that would rupture human arteries. But there's something else that makes each giraffe unique. Something we can see from 100 yards away if we know how to look. The spots, every single one different. We've all seen giraffes at zoos, in documentaries, on screens showing the African savanna at sunset, those distinctive brown patches against lighter skin. But here's what we usually miss. If you photograph 2 giraffes standing side by side, their spot patterns won't match, not even close. The shapes differ, the sizes vary, the borders curve in different directions. One giraffe might have circular spots with smooth edges, another shows irregular patches with jagged borders. Think about your own fingerprints for a moment, the whorls and loops that make you uniquely identifiable. No 2 people share the same pattern. Giraffes carry that same uniqueness, but written across their entire bodies. Researchers in Tanzania have photographed thousands of giraffes over the years, building databases of spot patterns. Not once have they found 2 individuals with identical markings, not siblings, not twins born minutes apart. Every giraffe wears a pattern that belongs to them alone. This creates an interesting challenge for us. When you're trying to study wild giraffes, you need to know which individual you're observing. Is this the same giraffe we saw 3 months ago? Has she traveled 20 miles since we last photographed her? Traditional tagging methods don't work well with these animals. You can't exactly put a collar on a neck that long. Radio tags fall off, physical markers fade or get damaged, but the spots never change. A giraffe born with circular patches on the right side of its neck will carry those same circular patches for its entire life. The pattern emerges before birth, coded somehow into the development of the animal. By the time the calf stands for the first time, the spots are there, fixed, permanent. Researchers discovered they could use this. They started taking photographs, thousands of them, right side, left side, close-ups of the neck and shoulder area where patterns show most clearly. They fed these images into software originally designed for facial recognition. The algorithms learned to identify individual giraffes with the same accuracy we use to unlock our phones with our faces. And here's what makes it more fascinating. The spots aren't symmetrical. Your left side doesn't mirror your right side. If we photograph a giraffe's left flank, we can only match it to other photographs of that same left flank. The right side pattern differs completely. This means we need photos of both sides to track an individual reliably. More work for researchers, more time spent following giraffes across the savannah, but it works. Now we can watch individual animals over years. We know where they travel, who they spend time with, how long they stay in one area before moving to another. All from photographs of spots that never change. But there's something we didn't expect to find. A pattern within the patterns. Researchers in northern Tanzania spent 4 years photographing mother giraffes with their calves. They wanted to know if spot patterns served any survival purpose. Did certain patterns help young giraffes survive their first dangerous months? Did the markings affect how well calves could hide from predators? They photographed 31 mother-calf pairs, hundreds of other young giraffes. Then they measured everything: spot size, spot shape, how circular each patch appeared, how smooth or jagged the borders were. 11 different traits that could vary from one animal to another. The data revealed something unexpected. Mothers and their calves shared certain spot characteristics. Not all of them, but 2 traits showed striking similarity. Circularity, how close the spots came to forming perfect circles, and solidity, how smooth and complete the borders appeared. Think about that for a moment. You're not looking at random patterns. These markings pass from mother to offspring. The calf inherits aspects of its mother's coat design the same way it inherits eye color or height. The spots aren't accidents of development, they're family traits. This changes how we understand what we're seeing. When a researcher photographs a calf with unusually circular spots, they can predict what the mother's pattern might look like. When they find 2 giraffes with similar spot characteristics, they start asking if these animals might be related. The patterns become tools for understanding family connections in populations that don't stay together in fixed groups. Wild giraffes move through shifting social networks. A mother and her calf might spend weeks with one group, then drift into another. Adult females come and go, males wander alone or form temporary bachelor groups. There's no permanent herd structure the way we see in elephants or buffalo. Everyone's always moving, mixing, separating. So how does a giraffe recognize family? How does a mother find her calf in a group of 20 other young giraffes? The spots might provide the answer. If calves inherit certain pattern characteristics from their mothers, then mothers can use those visual cues to identify their offspring. A quick glance confirms relationship. No need for scent marking or extended visual searches. We see this possibility play out in the data on calf survival. Young giraffes with certain spot characteristics lived longer than others. Specifically, calves with larger spots and slightly irregular but smooth borders survived their first few months at higher rates. The opposite, small spots with very jagged edges, correlated with lower survival. Why would spot pattern affect survival? The obvious answer involves camouflage. Young giraffes spend their first weeks hiding in dappled shade beneath acacia trees. When a lion walks past, the calf freezes. Its survival depends on not being seen. Spots that break up the body outline, that blend with moving shadows and filtered sunlight, might provide just enough concealment to tip the odds toward survival. But there's another possibility: temperature regulation. Each spot sits above a network of blood vessels closer to the skin surface. These areas can dissipate heat more efficiently. A calf with larger, more numerous spots might regulate its body temperature better during the hottest parts of the day. Better temperature control means more energy for growth. More energy for growth means stronger legs, faster reactions when predators approach. Or perhaps the spots serve as social signals. Maybe mothers recognize their calves partly through pattern matching. Maybe calves learn to identify other family members the same way. If spot similarity indicates kinship, and if giraffes can perceive that similarity, then the patterns become communication tools. Visual indicators of relationship that work across distances too far for scent or sound. We're still figuring out which explanation fits best. Probably all three factors play some role. These features rarely serve just one function. A trait that helps with camouflage and temperature regulation and social recognition gets selected more strongly than one that only does one job. But here's what we know for certain now. The spots matter. They're not decorative accidents. They affect survival. They pass from mothers to offspring. They identify individuals across years and miles. They encode information we're only beginning to understand how to read. Researchers are now measuring spot patterns across different giraffe subspecies. Each subspecies shows its own general pattern type. Maasai giraffes have the darkest spots, almost black, with irregular edges. Reticulated giraffes show perfectly straight-sided patches that fit together like a jigsaw puzzle. Angolan giraffes appear lighter, almost smoky. But within each subspecies, individual variation remains enormous. The family resemblance shows through, but every animal still carries a unique design. This opens new questions. Can we use spot patterns to track migration routes between populations? If we photograph a giraffe in Tanzania and later see the same individual in Kenya, we learn something about movement corridors and habitat connectivity. Can we identify breeding patterns? If certain spot characteristics correlate with reproductive success, we might predict which individuals will have more offspring. The patterns also help us monitor population health. When researchers photograph the same individuals year after year, they notice changes, not in the spots themselves, those never change, but in body condition, in group membership, in reproductive status. We build life histories from photographs. We track how many calves each mother produces. We document which individuals disappear and when, all because we can reliably identify every giraffe we encounter. There's something almost hypnotic about studying these patterns. You find yourself staring at photographs tracing the borders between dark spots and light skin, noticing how one giraffe's patches flow together while another's remain distinct and separate. Seeing family resemblances emerge across generations, the variation seems infinite, yet patterns repeat. Themes emerge, You start to recognize individuals not from perfect recall of their entire coat, but from characteristic features. That giraffe with the almost heart-shaped spot on the right shoulder, the one with 3 tiny circular patches in a row above the front leg. And the spots never fade, never blur with age. A giraffe photographed as a calf looks identical 20 years later, just stretched taller. The pattern expands as the animal grows, spacing out across more skin, but the shapes remain constant. The borders don't shift. What was circular at birth stays circular at maturity. This permanence makes long-term studies possible. We can follow individuals across decades if we keep photographing. We can watch how spot patterns correlate with life success. Do certain patterns predict longevity? Do they affect social status within shifting groups? These questions become answerable when we can track the same animals year after year, but we're left with the fundamental mystery. How do the patterns form in the first place? Something in the developing embryo creates these designs. Chemical signals spreading through skin tissue, genes turning on and off at specific locations. The process happens before birth, invisible, creating patterns that will last a lifetime. We understand that mothers pass certain characteristics to their offspring. We can measure the inheritance. But the mechanism, the actual biological process that paints these patterns onto developing skin, remains largely unknown. What we do know is this: every giraffe standing on the savannah right now carries a unique identifier visible from hundreds of yards away, a pattern that connects them to their mother, a design that might affect how long they live, a signature that researchers can use to follow their movements across landscapes and years. And tomorrow, when you see a giraffe, whether in person or in an image, you'll notice the spots differently. You'll see the individual rather than just the species. You'll wonder about that particular animal's mother, about whether those circular patches or irregular borders helped this giraffe survive, about what stories the pattern could tell if we knew how to read them completely. Chapter 4. Morning sunlight filters through acacia branches. A giraffe stands motionless beneath the canopy, neck extended upward. The tongue emerges 18 inches of dark purple muscle and curls around a single cluster of leaves. The branch bends slightly. The leaves disappear into the mouth. This scene repeats hundreds of times each day. Quiet, methodical, a rhythm that has continued for thousands of years across African savannas. We need to understand what's happening here, because feeding a body that weighs over 2,000 pounds requires careful decisions. Every bite matters. Every leaf chosen or rejected affects whether the giraffe maintains its energy through another day. The acacia tree stands as the centerpiece of giraffe diet, not because it's the only option available. Other trees grow across the landscape. Other leaves hang at heights the giraffe can reach. But acacias provide something unique. Protein levels higher than most savanna vegetation. Water content that sustains the animal through dry months. Calcium for maintaining that enormous skeleton. A large male consumes around 145 pounds of vegetation daily. For female giraffes, the amount drops slightly but remains substantial. That volume of food doesn't appear in one location. The giraffe moves between trees, selecting carefully, spending up to 70% of daylight hours feeding. Picture the process from the animal's perspective. You approach an acacia, dozens of branches spread before you at various heights, Thousands of leaves hang within reach, but not all leaves provide equal nutrition. New growth at branch tips contains more protein, less fiber. Older leaves deeper in the canopy offer less value despite being equally accessible. The giraffe somehow knows this distinction. The neck extends, the head tilts at an angle that brings the mouth close to a specific cluster. The tongue emerges and wraps around leaves with precision that seems impossible given the tongue's length. Each movement looks effortless, but consider the control required. That tongue measures nearly 2 feet from base to tip. It's prehensile, meaning it can grip and manipulate objects the way an elephant's trunk does. But unlike a trunk, the tongue must navigate between thorns that can reach 4 inches in length. Acacia thorns aren't decorative. They're sharp enough to puncture vehicle tires, long enough to inflict serious wounds, positioned at angles that make casual browsing dangerous for most herbivores. Yet the giraffe tongue moves between them as if the thorns don't exist. The surface of the tongue feels rough, covered in small bumps that provide grip without requiring pressure that might slide against a thorn edge. The saliva coating everything helps too, thick and sticky enough to cushion any thorn that does make contact. Watch closely and you'll notice the giraffe targets specific leaves, not the ones closest, not necessarily the largest clusters. The animal chooses new growth, the tender shoots that appeared in recent weeks. These leaves hang at branch tips, often surrounded by the densest thorn coverage. Reaching them requires the most careful tongue work, but the nutritional reward justifies the effort. The tongue curls, the leaves pull free from the branch, the mouth closes around them. This single action, repeated 1,000 times per day, provides everything the giraffe needs to survive. Protein for maintaining muscle mass, carbohydrates for energy, water for circulation in a body where every drop must climb 6 feet of neck to reach the brain, minerals for bone strength in a frame that supports enormous weight while remaining light enough for the animal to run. But the acacia tree doesn't surrender its foliage willingly. When a giraffe begins feeding, the tree responds. Chemical signals spread through the plant tissue. Within minutes, leaves throughout the canopy start producing compounds called tannins. These chemicals taste bitter. They interfere with digestion. They make continued feeding unpleasant enough that most animals stop and move to a different tree. The giraffe typically feeds on one acacia for 10 to 15 minutes before the taste changes noticeably. Then it walks away, moving to another tree 50 or 100 yards distant. This pattern continues throughout the day. Feed, move, feed again, move again. The trees get browsed but never stripped bare. The giraffe gets nutrition without encountering high tannin levels that would make digestion difficult. Here's where the interaction becomes more interesting. When one acacia releases tannins in response to browsing, it also releases ethylene gas into the air. This gas drifts downwind, carried by whatever breeze moves across the savanna. Other acacias detect it. Their own tannin production increases even though no giraffe has touched them yet. The trees communicate, warning each other that browsing pressure has arrived. This means the giraffe must pay attention to wind direction. Feeding downwind from a browsed tree brings you to acacias that have already raised their defenses. Their leaves taste bitter from the start, but moving upwind takes you to trees that haven't received the chemical warning yet. Their leaves remain palatable. The giraffe can feed for those 10 to 15 minutes before the taste changes and it's time to move again. Researchers have watched giraffes navigate this system with consistent success. The animals don't make random choices. They don't simply walk to the nearest tree. They angle upwind. They space their browsing across multiple trees in a pattern that avoids recently warned acacias. Whether this represents learned behavior or something else remains unclear, but the strategy works. Now consider the timing. Tannin levels in browsed acacias remain elevated for roughly 2 days. After that, the concentrations drop back to baseline. The tree can be browsed again without immediate bitterness. This creates a rotation system. The giraffe feeds from trees A, B, and C on day 1. By day 3, when it circles back to the same area, tree A has returned to normal tannin levels. The feeding cycle can repeat. During wet season, when rain brings new growth and abundant foliage, giraffes can be more selective. They target the newest shoots exclusively, the ones with highest protein content and softest texture. Trees respond by growing back quickly, producing more foliage that will be browsed again in the next feeding cycle. During dry season, options narrow. The giraffe still prefers new growth but will accept older leaves, bark, even seed pods when necessary. The acacia remains the primary food source, but other tree species get utilized more heavily during months when water becomes scarce. The feeding position itself requires consideration. When browsing from heights at or above head level, the giraffe can maintain its natural stance. Neck extended, legs straight, the entire body aligned for efficient circulation. Blood flows normally. The heart doesn't work harder than baseline. But some nutritious leaves grow on lower branches. Reaching them means bending the neck down, sometimes bringing the head below shoulder level. This position creates circulatory challenges we discussed in earlier chapters. The giraffe can maintain it for short periods, but not comfortably. Most browsing happens at heights between 10 and 18 feet, the range where the animal can feed without straining its cardiovascular system. Males and females show slightly different feeding patterns. Males, being taller, tend to browse from higher branches. Females prefer levels 4 to 6 feet lower. This difference reduces competition between sexes. A mixed group can feed from the same tree simultaneously without depleting any single height layer too quickly. Young giraffes browse lower still, working vegetation that adults mostly ignore. Everyone gets food without directly competing for the same leaves. The mouth itself shows adaptations for this diet. Thick tissue lines the tongue, lips, and palate, hard enough to resist thorn punctures, tough enough that even swallowed thorns cause no damage as they pass through the digestive system. The lower jaw features specialized teeth that work with a hard upper pad to strip leaves from branches. When the giraffe closes its mouth on a stem, the leaves pull free while the stem remains attached to the tree. Efficient, minimal waste. The plant can generate new growth from those same stems. Digestion follows the pattern common to ruminants. The giraffe has a 4-chambered stomach. Food goes down initially with minimal chewing. It sits in the first stomach chamber where bacteria begin breaking down plant fibers. Hours later, the partially digested material returns to the mouth. The giraffe chews this cud thoroughly, grinding it into smaller particles. This second chewing can happen while the animal walks, while it stands in shade during midday heat. even while it rests at night during those brief periods between sleep fragments. The cud-chewing process takes time. We see giraffes standing still for long stretches, jaws working steadily, seemingly doing nothing. But they're actively digesting, processing the morning's browse, preparing it for the next stomach chambers where further breakdown will occur. This multi-stage digestion extracts maximum nutrition from each leaf. Nothing goes to waste. The efficiency allows giraffes to maintain their body weight on vegetation that seems sparse compared to what other large herbivores require. Water comes primarily from the leaves themselves. During wet season, giraffes may go months without drinking from rivers or waterholes. The moisture content in fresh acacia foliage provides enough hydration. Only during the driest months does the animal need to drink directly. Then it visits water sources every 3 or 4 days, consuming up to 10 gallons at once. The drinking posture requires spreading the front legs wide, lowering the neck to ground level. Vulnerable. Slow to escape if danger approaches. The giraffe minimizes time spent in this position, drinking quickly then returning to its normal stance. Some acacias have additional defenses beyond thorns and tannins. Certain species host ant colonies that live in hollow thorns at the tree's base. When browsing disturbs these thorns, the ants emerge and attack. Their bites cause pain. Their formic acid sprays irritate skin. For most herbivores, this would end the feeding attempt, but giraffes have learned to browse from higher branches above where the ant colonies nest, or they feed briefly, taking a few mouthfuls before the ants fully mobilize, then move to another tree. The strategy works often enough that ant-guarded acacias still get browsed regularly. The relationship between giraffe and acacia tree creates balance across the ecosystem. The trees provide food that keeps giraffe populations healthy. The giraffes, through selective browsing, encourage trees to produce more nutritious new growth. Neither dominates, neither gets eliminated. Both exist in a pattern that has continued across countless generations. And every morning, as sunlight touches the savanna, giraffes return to the acacias. The tongue extends, the leaves disappear. The quiet rhythm continues. Chapter 5. Afternoon light falls across the savanna. A giraffe stands beneath an acacia, neck extended toward a cluster of leaves. The mouth opens slightly, then the tongue emerges. 18 inches of dark purple muscle, moving slowly through the air, curling around a single branch. The motion looks effortless, almost lazy in its precision. This tongue accomplishes what seems impossible. It navigates between thorns 4 inches long. It selects individual leaves from dense foliage. It works for 12 hours each day without injury, without rest, pulling nutrition from trees designed to resist exactly this kind of browsing. The color catches your attention first, not pink like you might expect, not red or pale, dark purple at the front, fading to almost black at the tip. The base, hidden inside the mouth, shows a more familiar pink tone, but the working portion, the part that emerges into sunlight, carries that distinctive purple hue. Scientists believe this coloring serves a practical purpose. The tongue spends hours in direct African sun, extended, exposed, working among leaves and branches while ultraviolet radiation beats down constantly. That dark pigment comes from melanin, the same substance that darkens human skin during sun exposure. In the giraffe's tongue, melanin acts as protection. a biological sunscreen built into the tissue itself. Without this protection, the tongue would burn. Imagine your own tongue spending 12 hours in midday sun. The pain would be immediate, the damage severe. But the giraffe's tongue handles this exposure day after day, year after year, without apparent discomfort. The length creates its own advantages. 18 to 20 inches from base to tip, roughly the length of a human forearm. This extension allows the giraffe to reach leaves its mouth alone cannot access, an extra foot and a half of reach beyond where the lips can grip. Deep into the canopy, around corners of branches, into clusters of foliage that would otherwise remain untouched. The tongue doesn't just extend, it grasps. The tip can curl completely around a branch, wrapping the way your fingers might wrap around a pencil. This prehensile ability mirrors what elephants do with their trunks or monkeys with their tails. The tongue acts as an additional limb, controlled with remarkable precision despite its length. Watch the motion closely. The tongue emerges from between the lips. It extends toward the target leaves. The tip curls around the branch just below the leaf cluster. Then it pulls, stripping the leaves cleanly from the stem while leaving the branch intact. The entire sequence takes perhaps 2 seconds. Then the tongue retracts, carrying the leaves into the mouth where teeth can begin processing them. This happens hundreds of times each hour, thousands of times each day. The tongue never seems to tire, never loses coordination. Each movement flows into the next with consistent rhythm. The surface of the tongue shows texture. Small bumps cover the top and sides. These papillae feel rough to the touch, providing grip on smooth leaves. They also serve as armor. The bumps create a layer of protection against the thorns the tongue encounters constantly. When a thorn makes contact, it hits these raised surfaces rather than penetrating into softer tissue beneath. Saliva coats everything, thick, sticky fluid produced continuously by glands at the tongue's base. This saliva serves multiple purposes. It lubricates the tongue, allowing it to slide between thorns more easily. It coats any thorns that do get swallowed, preventing them from causing damage as they pass through the digestive system. It even contains antiseptic compounds that help minor cuts heal quickly if the tongue does get scratched. The combination of protective features, dark pigment, thick skin, rough papillae, antiseptic saliva, creates a tool designed specifically for one task: gathering leaves from thorny trees. Nothing else in the giraffe's environment requires exactly these adaptations. But for accessing acacia foliage, the system works perfectly. The tongue's flexibility allows it to work at multiple angles. Sometimes the giraffe feeds from branches directly overhead, tongue reaching straight up. Other times the target sits to one side, requiring the tongue to extend laterally. The muscle tissue adjusts, curving and bending to reach whatever leaves the giraffe has selected. This flexibility comes from how the tongue attaches inside the mouth. Unlike tongues in many other animals, the giraffe's tongue inserts deeper into jaw muscles, allowing greater range of motion. Temperature affects how the tongue performs. During the coolest morning hours, the tissue might move slightly more slowly, warming up as feeding begins. By midday, when heat peaks across the savanna, the tongue works at maximum efficiency. The dark pigment absorbs some heat, but the saliva coating helps regulate temperature, keeping the working surface from overheating even during prolonged exposure. The giraffe can control different sections of the tongue independently. The tip might curl around a branch while the middle section remains straight, extending toward the next cluster of leaves. This sectional control resembles how your fingers can move independently while your hand remains still. It allows the giraffe to maintain continuous feeding motion, always reaching for the next mouthful while processing the current one. Baby giraffes are born with fully functional tongues. Within hours of birth, calves begin using their tongues to nurse, then to sample leaves their mothers select. The purple coloration appears from the start, already providing sun protection, even though young giraffes initially feed at lower heights, where shade is more common. As the calf grows, its tongue lengthens proportionally, maintaining the same 18 to 20-inch measurement relative to body size. The tongue can reach places beyond just food gathering. Giraffes regularly use their tongues to clean their own nostrils, extending the tip up into the nasal passages to remove dust and debris. They can reach their ears, cleaning out buildup that would otherwise accumulate. This grooming function adds value beyond feeding, helping the animal maintain hygiene in an environment where dust and insects constantly present challenges. Males use their tongues during courtship, though in ways we'll skip describing in detail here. The tongue serves multiple social and biological functions beyond the obvious feeding role, but nutrition remains its primary purpose. Every other use is secondary to the daily task of gathering enough leaves to sustain a body that weighs more than a small car. The muscles controlling the tongue show impressive strength. They can snap small branches, can pull against significant resistance when leaves don't release easily from their stems. Yet that same strength operates with delicate precision when selecting individual leaves from a dense cluster. The giraffe never seems to grab the wrong leaf by accident, never pulls too hard and breaks the branch unnecessarily. The control remains consistent whether the animal feeds leisurely in late afternoon or more quickly during early morning when hunger drives faster consumption. Researchers have measured how much force the tongue can exert. The numbers translate to several pounds of pulling power at the tip, enough to bend flexible branches significantly, enough to strip bark if the giraffe chooses, though this happens rarely. The strength exists as backup, available when needed but typically unused because gentle manipulation works more efficiently. The tongue rarely shows signs of wear despite constant use. Unlike teeth, which can crack or break, the tongue remains flexible and functional throughout the giraffe's life. The tissue regenerates quickly if damaged. Small cuts heal within days. The surface remains sensitive enough to detect subtle differences in leaf texture, allowing the giraffe to reject older, tougher leaves in favor of younger, more nutritious growth. At night, when feeding slows, the tongue rests inside the mouth. The muscles relax. The tissue recovers from the day's work. By morning, everything functions at full capacity again. This cycle repeats daily for years, sometimes decades, with minimal degradation in performance. The sight of a giraffe's tongue working among thorny branches creates an impression of something almost impossible. The thorns look sharp enough to cause serious injury. The leaves seem barely accessible even with that extraordinary reach. Yet the tongue navigates this environment with consistent success, gathering nutrition from a food source few other animals can exploit. And tomorrow, when the sun rises over the savanna again, the tongue will emerge Once more, purple, long, precise, ready to begin another day of gentle work among the thorns. Chapter 6. Late afternoon. The waterhole sits quiet beneath open sky. A giraffe approaches slowly from the tree line. It stops 30 feet from the water's edge, stands still, watches the surface for long minutes. Other giraffes stand nearby, some at the water already, others waiting their turn. Nobody rushes. The scene moves at its own pace, dictated by caution and the simple physics of reaching ground level when you stand 18 feet tall. The giraffe takes another step forward, then another. It reaches the water's edge, pauses again. The head lowers slightly, surveying. Then the front legs begin to move. One leg shifts outward, then the other. Slowly, carefully, the stance widens. The legs spread until they form a wide angle, each hoof planted firmly in the soft earth at the waterhole's edge. The body lowers between them. The neck, that remarkable 6-foot extension, begins its descent toward the surface. This position looks unusual to us. We're built to bend at the waist, to crouch, to kneel. Our bodies fold naturally toward the ground. But the giraffe's proportions don't allow such movements. The legs are too long. The neck, despite its length, doesn't quite compensate for the distance between shoulders and ground, so the animal must widen its base, creating a lower center point from which the neck can reach down. The process takes time. Each adjustment happens deliberately. The legs shift a few more inches apart. The knees bend slightly, just enough to drop the shoulders another foot. The neck extends downward at an angle, following a careful path toward the water's surface. The whole body works together, maintaining balance while lowering the mouth to drinking level. Finally, the lips touch water. The tongue dips below the surface, and the giraffe begins to drink. We can't see what happens inside during this moment. The throat, the muscles working, the water moving upward through that impossibly long neck. But we know it happens. The giraffe drinks steadily for a minute, sometimes 2, small amounts at a time. The throat contracts rhythmically. Water climbs from lips to stomach, traveling that vertical path, 1 measured swallow at a time. Then it's done. The head lifts. The neck straightens. The legs, still spread wide, support the body as it rises back to standing height. The stance narrows gradually. One leg moves inward, then the other. Within moments, the giraffe stands normally again, as if that unusual position never happened. But it did, and it will happen again whenever water is needed, which isn't often, as it turns out. Giraffes can go days without drinking, sometimes weeks during wet season when leaves hold enough moisture. The acacia foliage they browse contains water alongside nutrition. Each mouthful of leaves provides a small amount of hydration. Over the course of a day, those small amounts add up. The animal stays hydrated through feeding alone. Only when dry season arrives does drinking become necessary. When leaves dry out and moisture content drops. When the savanna turns brown and waterholes become the only reliable source. Then giraffes visit water every few days, taking their turn at the drinking spots scattered across their range. The position itself creates certain challenges beyond just reaching the water. When the head drops 6 feet below the heart, blood flow changes, pressure shifts. We discussed earlier how the giraffe's circulatory system handles the opposite situation when the head rises high and blood must be pumped upward. But lowering the head presents different concerns. Blood wants to follow gravity. When the head drops, blood rushes downward from the body. Vessels in the neck must handle increased volume suddenly. Pressure in the brain rises as more blood arrives than usual. Without safeguards, this could cause problems, but the giraffe's system includes those safeguards, the valves we mentioned before, positioned throughout the jugular veins, the special vessel networks at the brain's base. Everything works together to moderate the pressure change, keeping it within safe limits, even when the animal bends into that unusual drinking stance. The position also affects visibility. When standing normally, the giraffe can see across great distances. The height provides a natural vantage point. But when bent over with legs spread and neck lowered, the field of view narrows dramatically. The animal can see the water surface, can see the ground immediately nearby, but the broader landscape disappears from view. Hills in the distance, trees across the plain, other animals moving through the area, all hidden temporarily while the head stays down. This reduced awareness explains why giraffes rarely drink alone. Watch any water hole long enough and you'll notice the pattern. Multiple animals approach together. One drinks while others stand upright, watching. Then they switch. The drinking animal lifts its head and another takes a turn, lowering into that vulnerable position. This rotation continues until everyone has drunk their fill. Nobody stays down longer than necessary. Nobody leaves the group unguarded. The time spent drinking varies, sometimes just 45 seconds, sometimes 2 minutes, or slightly more. The amount consumed depends on how long since the last drink, how much moisture the recent diet contained, how hot the weather has been. But regardless of duration, the pattern remains consistent. Approach, spread the legs, lower the neck, drink, rise, resume normal stance. Young giraffes learn this process early. Calves born during dry season may need to drink within their first few weeks. At that age, their proportions differ from adults. The legs haven't reached full length yet. The neck remains shorter relative to body size. Young giraffes can often reach water with less extreme leg spreading, sometimes even bending their knees more than spreading their starts. But as they grow, as legs lengthen and the body rises higher off the ground, they gradually adopt the wider stance their proportions require. The soil around waterholes shows evidence of this behavior. Giraffe tracks appear in pairs, widely spaced. Front hooves leave imprints 3 or 4 feet apart, sometimes more. The distance between tracks tells you exactly how wide the animal spread its legs to drink. Deep impressions indicate weight pressing down as the animal lowered and then raised itself. Shallower marks around the edges show where hooves shifted, adjusting position to maintain balance. These drinking spots become regular stops on the giraffe's daily movement pattern. The same waterhole might see the same individuals every 3 or 4 days. They arrive at similar times, usually morning or late afternoon, when temperatures moderate slightly. Midday heat keeps most animals in shade, conserving energy rather than making the trip to water. But as the sun's angle softens, movement resumes. Giraffes drift toward their familiar drinking locations, joining others who have timed their arrival similarly. The actual drinking motion involves more than just placing lips to water. The mouth must create suction. The tongue and jaw work together, drawing water up and back. Each swallow requires coordination between multiple muscle groups. The action repeats steadily, almost mechanically, until enough water has been consumed. Then the process reverses, the swallowing stops, the muscles relax. The head can lift. We mentioned earlier that standing up from the drinking position takes time. The legs must shift inward slowly, the shoulders rise gradually as the stance narrows. Any rapid movement risks losing balance. A giraffe can't simply jump upright the way a smaller animal might. The mechanics don't allow it, so the rising happens with the same deliberate pace as the lowering. Steady, controlled, safe. Once upright again, the giraffe typically stands quietly for a minute or two. The body adjusts, circulation stabilizes. The head returns to its normal position, high above the shoulders. The animal might look around, reassessing the surroundings now that full visibility has returned. Then it walks away from the water hole, making room for the next animal waiting its turn. This entire sequence from approach to departure might take 10 minutes, sometimes less if the giraffe drinks quickly and leaves. Sometimes more if it hesitates, waits for others, or drinks in multiple brief sessions rather than one longer one. But however long it takes, the sequence always includes that distinctive moment when the legs spread wide and the body lowers into a position unlike anything else the animal does during normal daily activity. And tomorrow, or 3 days from now, or whenever the body signals that more water is needed, the giraffe will return. We'll approach the water hole with the same caution. We'll spread its legs again into that careful stance. We'll lower its neck to the surface and drink what it needs before rising back to full height and continuing across the landscape where it makes its living. The routine never changes, the position remains the same. The water hole waits quietly and the giraffes keep coming back, one after another, bending down to meet the surface in the only way their proportions allow. Chapter 7. Morning light spreads across the savannah. 3 giraffes stand beneath an acacia, feeding quietly. By afternoon, one has wandered away. 2 others have joined. By evening, the group looks entirely different from how it started. This pattern repeats daily. Giraffes come together, stay for a while, then drift apart. No announcements, no farewells, just gradual shifts in who stands near whom. We call these groupings herds, but they don't resemble herds of other animals you might know. Elephants stay together for years, led by experienced matriarchs. Zebras maintain stable family unit. Buffalo form massive groups that move as one. But giraffes, their groups flow like water, constantly changing shape. A typical group might hold 3 to 10 individuals, sometimes just 2. Occasionally 20 or more when conditions bring many animals to the same waterhole or feeding area. But whatever the size, the membership changes regularly. The giraffe standing beside you today might be half a mile away tomorrow, feeding with completely different companions. This doesn't mean giraffes live alone. They're social animals, choosing to be near others most of the time. But the choice of which others varies. Today's neighbor becomes tomorrow's distant acquaintance. Yesterday's feeding partner might not reappear for weeks. Female giraffes with young calves show slightly different patterns. Mothers often gather near each other, creating what researchers call nursery groups. These groupings last longer than typical associations, sometimes holding stable membership for several months. The calves play together while mothers take turns watching over them. One female browses while others keep alert, then they switch. This cooperation allows everyone to feed while maintaining constant supervision of the young. But even nursery groups eventually dissolve. As calves grow older, mothers begin spending more time apart. By the time a calf reaches its first year, the tight-knit nursery arrangement has loosened. The mother might still appear near the same females occasionally, but the daily proximity fades. Adult females without dependent calves move even more freely. They might spend several days near one set of companions, then shift to another area and join different animals. Some females show preferences, appearing together more often than chance would predict. These preferred associations can last for years. Researchers have documented female pairs staying loosely connected across multiple seasons. But loose connection doesn't mean constant proximity. Even preferred companions might go weeks without crossing paths. Males follow different patterns. Young males often gather in small bachelor groups. 3 or 4 animals feeding together, moving through the landscape as a loose unit. These groups help young males learn from each other, how to assess other males, where to find the best feeding areas, which times of day offer the safest drinking opportunities. The bachelor phase typically lasts several years before males begin their more solitary adult life. Older males spend increasing amounts of time alone. They still join groups periodically, especially when seeking females. But long stretches of solitary movement become more common with age. An old male might browse alone for days, only joining others briefly at waterholes before wandering off again into the open landscape. This social fluidity creates interesting patterns when you watch giraffes over time. The same waterhole might see 15 different combinations of animals across a single week. Monday brings 5 females and 2 calves. Tuesday shows 3 males and 1 female. Wednesday finds a solitary old male drinking while younger animals wait nearby. By Thursday, the group consists of animals you haven't seen there all week. Yet within this constant reshuffling, certain relationships persist. Mothers and their offspring stay connected even after the calf no longer depends on constant care. Adult daughters might appear near their mothers occasionally throughout their lives. Sisters seem to cross paths more regularly than would happen randomly. The connections exist, but they flex and stretch rather than binding individuals together constantly. The lack of rigid structure offers advantages. When food becomes scarce in one area, individuals can split off and seek better feeding grounds without disrupting a larger herd. When one zone experiences drought, animals disperse widely to find remaining resources. This flexibility allows giraffes to adapt to changing conditions quickly. They're not locked into following a leader or maintaining group cohesion at the cost of individual needs. Communication among giraffes happens mostly through visual signals rather than vocalizations. A head position indicates awareness or interest. Ear angles show alertness levels. Body postures convey dominance or submission. These signals work well for animals whose height allows them to see each other across considerable distances. 2 giraffes a quarter mile apart can read each other's basic state simply by watching. The silence reinforces their peaceful nature. Giraffes don't argue loudly, don't call out aggressively. Conflicts get resolved through subtle postural displays rather than confrontation. A taller animal positions itself in a certain way. The shorter one acknowledges this with a shift in stance. Everyone understands the social ranking without needing to prove it through any aggressive display. resting patterns show similar individuality within loose social frameworks. During midday heat, several giraffes might rest near each other in scattered shade, but they don't cluster tightly. Each animal chooses its own spot, maintaining comfortable distances. Some stand while resting, others lie down briefly, legs folded beneath their bodies. The group exists in the same general area, yet each member remains somewhat independent within it. Night brings everyone closer together, though never packed tightly. Giraffes sleeping in proximity offer mutual awareness. If one animal startles awake, the movement alerts others. This shared vigilance works without requiring close contact or coordinated sleeping arrangements. Simply being within visual range of others provides the benefits of group living while preserving individual space. Young calves receive care from multiple females, not just their mothers. When a mother browses, another female nearby might keep watch over the calf. This casual babysitting benefits everyone. Mothers can feed more efficiently. Calves stay safer through having multiple adults monitoring their welfare. The cooperation happens naturally without apparent negotiation or reciprocal arrangements. The spatial spread of giraffe groups varies with the landscape. In open grassland, groups can stretch across several hundred yards while still maintaining social connection through visual contact. Their height makes this possible. A giraffe on one side of this spread can see every other group member easily. In denser woodland, spacing tightens naturally, though never becomes cramped. Feeding time sees individuals working independently even when standing near each other. One giraffe strips leaves from the left side of a tree. Another feeds from the right. A third browses from a different tree entirely, 20 feet away. They occupy the same general space but pursue individual activities. This parallel independence characterizes most giraffe social time. Together, yet separate, connected yet autonomous, the coming and going creates an ever-shifting social landscape. Today's nearby companion becomes tomorrow's distant figure on the horizon. Next week might bring them together again, or they might not cross paths for months. This ebb and flow continues throughout their lives, creating social networks that exist more in possibility than in constant manifestation. Researchers tracking individual giraffes over years have mapped these networks. The connections form complex webs where every animal links to many others through varying degrees of association. Some pairs appear together frequently, others cross paths just a few times annually, yet all remain part of the same broader social community, connected through overlapping ranges and occasional encounters. This loose structure requires no leader, no dominant female directing movement, no established hierarchy determining who feeds first or drinks when. Each giraffe makes its own choices about where to go and with whom to associate. The resulting pattern looks chaotic from outside, but functions smoothly for those living within it. The flexibility extends to territory. Giraffes don't defend specific areas. They move where food and water availability dictate, sometimes covering large distances between seasons. This mobility means the same landscape might see different combinations of animals throughout the year as individuals respond to changing resources. Understanding this social system took time. Early observers saw the constant group changes and concluded giraffes lacked social structure entirely. But longer study revealed the subtle patterns, the preferred associations, the lasting connections between related females, the cooperation in calf rearing, the whole quiet system operating beneath the visible surface of constantly shifting groups. And each day, as the sun moves across the sky, the pattern continues. Animals drift together, feed peacefully in loose association, then wander apart again, no drama, no conflict. Just the gentle rhythm of social life lived through flexible connections and peaceful coexistence across the open landscape where they make their home. Chapter 8. Night settles over the savannah. Darkness spreads across the grassland. Stars appear overhead, countless and bright. The temperature drops slowly. A giraffe stands beneath an acacia, barely visible in the dim light. Another stands 100 yards away. A third somewhere beyond that. They're spread across the landscape, feeding quietly in the darkness. You might think they're alone, separated, each animal working independently through the night. But something passes between them, something we can't hear, a low sound, deep, barely there. It moves through the air like a whisper, like breath, like something felt more than heard. The frequency sits below what human ears can catch, around 90 cycles per second, right at the edge of our hearing range. Most of us would miss it completely. Researchers call it humming. The word doesn't quite capture it, not a melody, not a song, just a sustained tone that appears and fades through the quiet hours between dusk and dawn. The sound lasts a few seconds, sometimes longer, then silence returns, minutes pass, another hum drifts through the darkness, then another. The pattern continues through the night, each call adding to a conversation we're only beginning to understand. We don't know what these sounds mean yet, whether they carry information or simply maintain contact, whether one giraffe asks a question and another answers, whether a mother reassures her calf that she's still near, even though neither can see clearly in the dark. What we do know is this: the sounds happen, night after night, in zoos where researchers recorded them for years before realizing what they'd captured, in the wild where the calls blend into all the other nighttime sounds of the savannah. Daytime is different. Daytime belongs to vision. Giraffes have excellent eyesight. They can spot each other across miles of open landscape. A slight shift in posture communicates awareness. An angle of the head shows interest or caution. The body speaks through position and movement, clear as any voice in the bright daylight. But night removes that advantage. Night makes everything harder to see. Shapes blur into shadows. Distance becomes difficult to judge. The visual signals that work so well during the day fade into uselessness when darkness falls. So the humming begins. Quiet communication for the hours when eyes can't help. A way to say "I'm here" without alerting every creature across the landscape to your presence. The sound doesn't travel like the roar of a lion, doesn't announce itself boldly. Low frequencies move differently through air. They spread gently, covering distance without much volume. A giraffe a quarter mile away might catch the hum, even though a person standing next to the calling animal barely notices anything. This creates a private network. Conversations that happen beneath the threshold of most listeners. Information passing through the darkness between individuals who know how to listen for it. Scientists spent years thinking giraffes were silent. Early observers watched them for months and heard nothing, assumed these massive animals simply didn't vocalize, made do with visual signals exclusively. The idea persisted for decades. Giraffes, the silent giants. Then better recording equipment arrived. Microphones sensitive enough to pick up very low sounds. Computer programs that could analyze hours of recordings, finding patterns human ears had missed. Researchers left equipment running through the night in places where giraffes lived, recorded everything, reviewed it all later. And there it was, the humming, present all along, happening every night while people slept or studied other things. The giraffes had been talking the whole time, we just hadn't been listening properly. The recordings show variation. Each hum sounds slightly different. Some last longer than others. Some carry different tonal qualities. Whether this variation means something, whether it encodes information, remains unclear. But the differences exist, the sounds aren't identical. Young giraffes seem to vocalize differently than adults, though the recordings don't always reveal which individual made which sound. Mothers and calves might use specific patterns to recognize each other, or perhaps age changes the quality of the hum, the way human voices deepen with maturity. We know even less about whether giraffes use sounds below human hearing entirely. Infrasound. Frequencies so low we'd never detect them without special equipment. Elephants communicate this way, send rumbles across miles of landscape, coordinating herd movements through calls we can't perceive at all. Giraffes might do the same. Their body structure could support it. The long neck, the large lungs, the resonating chambers in the head, all the necessary equipment seems to be there. But proving it happens requires even more sophisticated recording techniques than capturing the nighttime hums. Some researchers believe they've found evidence, others remain uncertain. The question stays open, waiting for more data, more nights of patient recording, more analysis, more attempts to hear what might be happening just beyond our sensory limits. Meanwhile, the humming continues every night. In the darkness, giraffes spread across the landscape, maintaining contact through sounds we're only just learning to recognize. The calls never grow loud, never become urgent or demanding. They simply exist. A steady, quiet presence in the nighttime hours, like breathing, like heartbeat, like any fundamental rhythm that continues whether anyone notices or not. Morning comes, light returns, the humming stops, vision takes over again. The giraffes resume their daytime communication, postures and positions replacing the sounds that serve them through the darkness. But when evening arrives again, when the sky darkens and stars emerge, the pattern repeats. The first hum drifts through the cooling air. Then another, the conversation resumes quiet and private, passing between animals who've been speaking this way for as long as giraffes have walked the earth. And we're finally beginning to listen. Chapter 9. Midday heat settles over the landscape. The sun hangs high and bright. Shadows shrink to small pools beneath trees. A giraffe stands in one of these shadows, perfectly still. Minutes pass. The animal doesn't move, doesn't shift weight, doesn't lower its head to browse. Just stands there, resting in the quiet warmth of afternoon. This is how giraffes spend many hours, standing, waiting, letting time drift past while their bodies rest and digest the morning's feeding. Not sleeping exactly, not fully awake either. Somewhere in between where awareness remains but activity stops. The spots they choose for this standing rest follow gentle patterns. Shade matters most. A spreading acacia provides cover from the direct sun. The temperature beneath the canopy stays several degrees cooler than in open grassland. Not dramatic relief, but enough to make the resting time more comfortable. Giraffes also prefer locations where they can see across distance. A slight rise in the land, the edge of a clearing, any place that offers visibility in multiple directions. Even while resting, they remain aware. Eyes stay open, though half-lidded. Ears move occasionally, tracking sounds. The body stays ready to respond if needed. Sometimes a giraffe leans slightly against a tree trunk, not heavily, just enough to take a bit of weight off the legs. The tree provides support. The giraffe can rest while remaining upright, ready to step away and move if anything changes in the surroundings. The standing position allows breathing to continue normally. Blood flows without stress. The heart works at its steady pace. Everything functions as it should, just at a quieter level while the animal rests. Hours can pass this way. The giraffe standing in shade. The day moving slowly forward. Other animals crossing the landscape at various distances. Birds calling from branches, insects humming in the grass. All the small sounds of afternoon blending together into a backdrop for rest. When the heat peaks, movement across the savanna slows nearly to nothing. Most creatures find shelter and wait. Giraffes do the same, though their height means they can't hide completely. They simply become still, like tall sculptures scattered across the landscape, patient and quiet. In the afternoon warmth, lying down happens less frequently, especially during daylight. The process requires folding those long legs beneath the body. Front legs bend first, lowering the chest to the ground. Back legs adjust, tucking in or extending slightly to the side. The whole sequence takes time and leaves the animal in a position that's harder to escape from quickly, so lying down tends to happen during safer moments. Early morning before the heat builds, late evening as darkness approaches, times when the landscape feels calmer, when the giraffe can afford those few minutes of deeper rest. When a giraffe does lie down, the position looks carefully balanced, legs folded underneath, body settled but not collapsed. The neck usually stays upright, keeping the head high enough to maintain some awareness of the surroundings. This allows the animal to continue chewing cud, that quiet rumination that happens throughout resting periods. Occasionally, for brief moments, the neck curves backward, the head lowers to rest on the animal's own hindquarters. This position looks almost impossibly bent, the long neck folding around on itself. But it works. The hindquarters provide a cushion. The head settles gently. The eyes close or nearly close. This deeply rested position doesn't last long, a few minutes at most. Then the head lifts again, the neck straightens. The giraffe returns to the more alert lying position or stands up entirely, ready to continue whatever the day requires. Young calves rest more often than adults. They have the luxury of being watched over. While mothers browse nearby, calves lie down in shaded spots, legs tucked beneath them, heads resting back on their rumps. They might stay this way for an hour or more, taking the longer rest their growing bodies need. Adult giraffes take turns in this watching role. One browses while others rest. Then they switch. This informal rotation means everyone gets feeding time and resting time, with the group maintaining awareness throughout. The actual sleep that happens during these resting periods comes in fragments, a few minutes here, a few minutes there. Standing or lying down, the sleep arrives in small doses scattered through the day and night. but the resting itself, the quiet standing or comfortable lying, fills many more hours than the true sleep. Favorite resting spots get used repeatedly. A particular acacia with good shade and clear sightlines might see the same giraffe return day after day during midday weekday heat. The animal knows the spot works, knows the shade pattern, knows the visibility it provides, so it returns, establishing a loose routine around that location. Water sources also influence resting patterns. After drinking, giraffes often rest nearby rather than immediately moving away. The trip to water takes energy. Better to rest briefly in the area before browsing back into the landscape. These post-drinking rests might last 30 minutes or an hour, the animals standing quietly near the waterhole's edge. During night hours, resting increases. Activity doesn't stop completely, but it slows. Giraffes might continue browsing between rest periods, but the browsing happens more slowly. More time gets spent standing still, letting darkness hide them while they recover from the day's movement. The night resting doesn't follow a schedule. A giraffe might rest for 20 minutes, browse for 15, rest again for 30. The pattern shifts based on factors we can't easily measure. Hunger, digestion needs, the presence of other animals nearby, small sounds in the darkness that might indicate something worth paying attention to. Groups resting together spread out rather than clustering. Each animal maintains personal space. They can see each other, can monitor each other's alertness levels, but they don't touch or press close. The spacing allows everyone room to stand quickly if needed without bumping into neighbors. Trees provide more than just shade. They serve as landmarks, meeting points. A giraffe might leave a resting spot to browse, then return hours later because that particular tree offers the right combination of shade, visibility, and familiar surroundings. Over weeks and months, these preferences create patterns, loose territories of favored resting locations scattered across an animal's range. The actual ground surface matters too. Rocky areas get avoided. Sharp stones make lying down uncomfortable. Soft soil or short grass works better, providing some cushioning for the weight of the body. Giraffes seem to assess these details without obvious deliberation, simply choosing spots that feel right when the time comes to rest. Weather shifts the patterns. During cooler periods, shade becomes less critical. Giraffes might rest in more open areas, taking advantage of the comfortable temperatures. When wind picks up, they seek more sheltered locations, standing in the lee of trees or small hills where the air moves less forcefully. Rain changes everything. Giraffes don't particularly enjoy getting wet. During showers, they often remain standing, waiting for the rain to pass. If it continues long, they might move to find better cover, but they rarely lie down when wet. The discomfort of a soaked hide seems to outweigh the benefits of resting. Season affects resting times too. During the lush wet season when food is abundant, giraffes can afford to rest more. The easy feeding means less time spent searching for nutrition. More hours become available for standing quietly in shade, digesting, waiting. Dry season brings different pressures. Food becomes scarcer. Water sources shrink. Giraffes must spend more time moving between feeding areas and remaining water sources. Resting time decreases. The animals push through longer active periods, grabbing brief standing rests when possible, but not lingering as long as they might during easier months. Through all these variations, the basic pattern holds. Giraffes rest often but briefly. They choose spots offering shade, visibility, and comfortable footing. They stand when possible, lie down when circumstances allow deeper rest. They maintain awareness even while resting, never quite letting go of that baseline vigilance that keeps them alive in a landscape where rest itself carries risk. And each day, as the sun traces its path across the sky, giraffes across the savannah settle into their resting spots, standing in shade, lying in protected areas, taking those quiet hours that balance against the active hours of feeding and moving. The rhythm continues, steady and ancient, as necessary as the feeding itself. Rest woven into the fabric of each day, allowing these tall animals to maintain their presence across the landscape they call home. Chapter 10. Dawn breaks quietly across the savannah. In a sheltered area beneath scattered acacias, a mother giraffe stands alone. Beside her, legs still uncertain, stands her newborn calf. They've been together for 3 days now, just the two of them. Away from other giraffes. Away from the usual movement and social interactions that fill most days. This time belongs to them. Mother and calf. Learning each other. The calf weighs around 140 pounds, stands roughly 6 feet tall already, born with those proportions after 15 months of gestation, 15 months of quiet development before arriving into the world through a 6-foot drop to the ground. That drop serves a purpose we won't detail here. What matters is what happens after. The mother turns immediately to her calf, begins licking, cleaning. The tongue moves across the small body, gentle and thorough. This contact establishes something fundamental between them: recognition, connection, the beginning of their relationship. The calf responds to this attention, struggles to find its legs. The first attempts fail. Long limbs fold awkwardly. The body tips, falls back to the ground. But the calf keeps trying. Within an hour, sometimes less, it manages to stand, wobbly, uncertain, but standing. The mother watches closely, positions herself to provide support if needed, continues the grooming, the care. Her entire focus remains on this small animal that just entered the world. These first hours set the pattern for weeks to come. The mother stays near. The calf learns to walk, to run, to coordinate movements that will eventually become graceful but start as clumsy attempts. They remain isolated from other giraffes, giving both time to establish their bond without the distractions a larger group would bring. The calf nurses frequently during these early days, approaches the mother, finds the right position. The milk provides everything the growing body needs: nutrition, hydration, antibodies that protect against various threats the calf will encounter as it explores its environment. Between nursing sessions, the calf rests, lies down in soft grass or beneath shade, legs folded beneath its body, head curved back to rest on its own hindquarters, the way all giraffes sleep when they allow themselves that vulnerable position. The mother stands nearby, never far, always watching. This vigilance matters because the calf cannot defend itself yet, cannot run fast enough to escape threats, cannot even recognize danger approaching. The mother provides all the protection during these vulnerable weeks. Her height gives her visibility across great distances. Her experience tells her which sounds, which movements, which shadows might indicate something requiring attention. When the mother needs to feed, she doesn't go far, perhaps 50 feet, perhaps 100 if the browse is sparse. She keeps the calf in sight, returns frequently to check. The calf often stays lying down during these brief separations, remaining still and quiet. This instinctive hiding behavior helps keep it safe when the mother cannot be directly beside it. Days pass in this routine, nursing, resting, short walks together as the calf grows stronger, the mother teaching through example, how to browse from low branches, how to position the body for comfortable standing, how to read the landscape for safe resting spots. After a week, sometimes two, the pattern begins to shift. Other females with calves appear nearby, not close enough to intrude, but visible, moving through the same general area. The mother and her calf start spending time near these other pairs, not joining them exactly, just existing in the same space. This gradual integration happens naturally. One day, the calf finds itself near another calf. They investigate each other cautiously. Stand close, maybe walk a few steps together. The mothers watch but don't interfere. This is how young giraffes begin learning social behavior. Through these tentative interactions with other calves their age, eventually a loose grouping forms, several mothers with their young. The calves gather together while mothers take turns staying alert. One female watches over the group. Others browse at a distance, taking advantage of the shared vigilance to feed more efficiently. After a while, they rotate. A different female takes the watching position. Everyone gets time to feed. Everyone's calf receives protection. These nursery groups, as researchers call them, function smoothly without apparent organization. The mothers seem to understand the arrangement instinctively. They space themselves appropriately, move between feeding and watching without discussion or conflict. The system works because everyone benefits. The calves seem to enjoy these gatherings. They have companions their own size, can run together, which they do increasingly as their legs grow stronger. Can learn from watching each other, how to reach leaves, how to spread legs for drinking when the group visits a water hole. All the small skills they'll need as they grow. The mother remains the primary attachment, though. Her calf stays closest to her, nurses from her, returns to her side when tired or uncertain. The other calves are companions, but the mother is home base, the secure point from which everything else can be explored. As weeks turn into months, the calf grows rapidly. Height increases, weight nearly doubles by the end of the first year. The legs grow longer, making movement easier and more coordinated. The neck extends, allowing the young giraffe to browse from higher branches. Independence increases gradually, but the connection with the mother persists. Even as the calf becomes more capable, more confident, it stays near her, follows her movements, learns her feeding preferences, observes how she selects resting spots and responds to changes in the environment. Male calves eventually begin spending more time away from their mothers. By 15 months or so, they start drifting toward other young males, form loose bachelor groups. The separation happens gradually. A day away, then back to the mother, then 2 days. Eventually the visits become less frequent, though the young male might still appear near his mother occasionally for another year or more. Female calves often maintain closer relationships. They might stay in the same general area as their mothers throughout their lives, not constantly together, but within the same loose social network, sometimes appearing in the same feeding groups, sometimes meeting at water holes. The connection flexes but doesn't break completely. During these months of growth and gradual independence, the mother continues her protective role. She positions herself between her calf and potential threats. She watches the horizon constantly. She guides the young animal away from situations that might be dangerous. This constant low-level supervision happens so naturally it's barely visible unless you watch closely. The calf learns by absorbing these patterns how to assess risk, where to find the best feeding areas, which times of day offer the safest drinking opportunities. All this knowledge transfers through observation and example rather than any obvious teaching. By the time the calf reaches its first year, it can survive independently if necessary, can feed itself effectively, can run fast enough to escape most dangers, can read the landscape well enough to avoid obvious threats, but it usually doesn't need to survive alone yet. The mother remains present, allowing the young giraffe to continue developing while still protected. This extended care period reflects the investment each calf represents. 15 months of gestation, months of nursing, years of protection and guidance. Each mother typically raises one calf at a time, though she might become pregnant again while still caring for her current offspring. The new pregnancy develops slowly while she continues caring for the existing calf, creating overlap between generations. And so the pattern continues. Across the savannah, mothers with calves, young animals growing, learning, eventually becoming mothers or wandering males themselves. Each generation passing knowledge to the next through quiet presence and patient example. The cycle steady and ancient, as natural as sunrise, as certain as the seasons that shape the landscape where these remarkable animals make their lives. Morning spreads slowly across the waterhole. The surface reflects pale blue sky and scattered clouds. Animals arrive gradually from different directions. First, a group of zebras, then several giraffes. An elephant family appears from the tree line. An ostrich picks its way through tall grass nearby. They gather at the same water source, not clustering together, not avoiding each other either, just sharing the space naturally, each following its own routine. This pattern repeats across the savannah every day, different species occupying the same landscape, using the same resources, existing alongside each other without conflict or competition. The arrangement works smoothly, has worked for countless generations, continues working still. Zebras and giraffes appear together frequently, sometimes at water, sometimes browsing in the same general area, though at different heights. The zebras crop grass from ground level. The giraffes work leaves from tree branches overhead. Neither interferes with what the other needs. The food sources don't overlap. The space accommodates both easily. Zebras move in tighter groups than giraffes, family units that stay together for years. One stallion leading several mares and their young. These stable groups travel through areas where giraffe groups constantly shift and change. Yet when the paths cross, nothing changes. The zebras continue their patterns, the giraffes maintain their loose associations. Both go about their business undisturbed. Elephants bring different dynamics. Their size alone commands attention. When an elephant family approaches a water hole, other animals tend to make space. Not from fear exactly, just respect for the sheer mass involved. An elephant drinks for several minutes, consuming gallons at a time. Smaller animals wait their turn. The wait isn't long. The elephants finish and move away. The giraffes step forward, then the zebras. Everyone gets what they need. Sometimes elephants and giraffes feed near each other. The elephants work on different vegetation entirely. They strip bark, break branches, push over small trees to reach leaves that were previously too high, even for giraffes. This destructive feeding actually helps. It opens up the canopy, allows sunlight to reach the ground. New growth sprouts. Young trees begin their slow climb toward the canopy. The cycle continues. Giraffes benefit from this without needing to interact with elephants directly. They simply feed on different resources. Browse from trees the elephants haven't touched, or wait until the elephants move on, then investigate what new growth the disturbance might have created. The relationship exists without requiring coordination or awareness from either species. Ostriches often appear where giraffes feed. The large birds don't compete for food. They eat seeds, insects, small plants from ground level, but they seem to choose locations near browsing giraffes more often than chance would predict. Researchers believe this happens because giraffes provide excellent early warning of approaching danger. Their height offers visibility that ostriches lack. When a giraffe suddenly becomes alert, lifts its head higher, focuses its gaze on something distant, nearby animals notice, including ostriches. The birds can't see what the giraffe sees, but they know something has changed. They become more cautious, more ready to run if needed. This passive benefit doesn't require the giraffe to do anything special. Simply by being tall and alert, it provides a service to smaller animals nearby. The giraffe doesn't intend this, doesn't know the ostrich is using its vigilance. But the pattern persists because it works. The ostrich gains protection. The giraffe continues its normal behavior. Both survive more successfully. Buffalo create different scenarios. These large, solid herbivores move in impressive herds sometimes, dozens or hundreds traveling together. When a buffalo herd passes through an area, it changes things temporarily. The sheer number of animals, the noise they make, the dust they raise, all this creates disturbance. Giraffes in the path of a buffalo herd simply move aside, wait for the herd to pass, then resume whatever they were doing before. No aggression, no territory defense, just patient accommodation of another species using the same landscape. Antelope of various types scatter across the savanna, Thompson's gazelles, impalas, springboks. Each species has its own preferences, its own patterns, but they all share space with giraffes regularly. The size difference means resources rarely overlap. A gazelle eating grass doesn't affect a giraffe browsing leaves 15 feet overhead. They can occupy the same location simultaneously without competing. Warthogs present an amusing contrast. These low-slung animals trot around on short legs, tails raised like antennas. They dig in soil with their tusks, searching for roots and tubers. Sometimes this digging happens right beneath a browsing giraffe. Neither seems to notice the other. The warthog focuses on ground level. The giraffe works far above. The vertical separation keeps them from interfering with each other. Birds use giraffes directly sometimes. Oxpeckers land on giraffe backs and necks. They walk across the animal's body, picking off ticks and parasites. The giraffe tolerates this attention, perhaps even benefits from having these pests removed. The birds get an easy meal, another relationship that works without requiring anything beyond what both animals do naturally. The mixing of species happens most obviously at waterholes. These gathering spots draw everyone during dry season. Morning might see giraffes, zebras, wildebeest, various antelope and warthogs all drinking from the same location within an hour. They don't arrive together, don't coordinate their visits, but the water draws them all and they've learned to share it peacefully. Timing becomes important only when predators might be present. If one species shows alarm, others pay attention. Zebras have excellent hearing, giraffes have superior vision, elephants can detect vibrations through their feet. Each species monitors different sensory channels. When one reacts to danger, the reaction spreads. Zebras bolt, giraffes lift their heads and prepare to run. Other animals become alert. This collective awareness helps everyone survive. But most of the time, no danger threatens. Most hours pass quietly. Animals feeding, resting, moving between locations. The landscape holds them all, provides for them all, asks only that they take what they need without preventing others from doing the same. The vertical layering of food sources makes this possible. Ground level belongs to grazers, zebras and buffalo cropgrass. Mid-level belongs to browsers that can reach lower branches. Kudu and Nyala work this zone. Upper levels belong to giraffes exclusively. Their height gives them access nobody else can match. This stratification means dozens of species can feed in the same area without directly competing. Each takes from its own level. The resources don't overlap significantly. Space matters too. The savanna offers room. Animals can spread out, don't need to crowd. When local resources thin, individuals simply move to new locations. The flexibility prevents competition from becoming serious. There's always another waterhole, always another tree, always another patch of grass. The abundance shifts seasonally, but it exists, and so the pattern continues day after day, season after season. Different species moving through the same landscape, using the same resources, existing alongside each other in arrangements that look casual but work perfectly. Nobody claims ownership. Nobody excludes others. The space belongs to everyone and no one. Shared habitat in its most fundamental form. Sunrise brings them all into view. Giraffes catching first light on their necks. Zebras already grazing in the cool morning air. Elephants moving slowly toward distant waterholes. Each species following its own rhythm within the larger pattern that holds them all together in this ancient landscape where they've learned to coexist without conflict, without competition, simply by being what they are and allowing others to be what they are too. Night has returned to the savanna. Stars fill the sky overhead. The air cools slowly. Somewhere in the darkness, a giraffe stands beneath an acacia, barely visible against the dark trunk. We've watched these animals move through their days and nights, seen how they sleep in fragments, how they manage blood flow through that impossible neck, how each one carries a unique pattern of spots that never changes, how they select leaves carefully from thorny branches, how they spread their legs wide to reach water at ground level. We've seen their loose social structures, how groups form and dissolve like water flowing, how they communicate through sounds we barely hear, how they rest in favorite spots scattered across their range, how mothers guard their calves through vulnerable early weeks, how they share space peacefully with zebras and elephants and countless other species. All of this happens quietly, without announcement, without drama, just the steady rhythm of life continuing as it has for longer than we can measure. The giraffe asks for nothing beyond what the landscape provides: leaves, water, space to move, safety to rest briefly when darkness falls. And the landscape provides. The acacias keep growing, the waterholes hold enough for everyone. The grasslands stretch far enough that space never becomes scarce. The system works because it's been working, because all the pieces fit together in patterns established long ago, because nothing takes more than it needs, because everything gives something back. The giraffe standing in darkness will feed through the night. We'll catch a few minutes of sleep standing upright. We'll watch the horizon for anything that might require attention. We'll exist through these quiet hours the way it exists through daylight hours. Present, patient, part of something larger than itself. Tomorrow morning, light will return. The giraffe will still be there, or another will have taken its place beneath that same tree. The pattern will continue, feeding, resting, moving. The gentle rhythm that defines their lives playing out across another day. We've learned that these animals live at extremes we can barely comprehend. 30 minutes of sleep, blood pressure that would destroy human hearts, 6-foot necks that require extraordinary systems to function. Yet they make it look effortless, make it look natural, because for them it is. This is simply how giraffes exist, how they've always existed, how they'll continue existing for as long as the savanna remains. The spots will keep marking individuals, the tongues will keep navigating thorns, the legs will keep spreading for drinking, the groups will keep shifting and reforming, the quiet humming will pass through darkness between animals we can barely see. Everything will continue because everything continues, because these patterns work, because nature found solutions to impossible problems and gifted them to these remarkable animals. And somewhere out there right now, across the African landscape, thousands of giraffes are living these patterns, standing in the darkness, browsing quietly, resting for brief moments before resuming their watch. Each one an individual, each one part of the whole, each one carrying forward the ancient knowledge written into their bodies about how to survive, how to thrive, how to exist peacefully in a world that demands constant vigilance while rewarding patient persistence. The night deepens, the stars wheel slowly overhead, the savanna breathes through its darkness, and the giraffes remain tall sentinels scattered across the landscape, quietly living their remarkable lives while we finally begin to understand how remarkable those lives truly are. Sleep well, knowing they're out there. Standing watch, surviving, continuing, being exactly what they've always been. Gentle giants moving through their world with grace we're only now learning to recognize. Tomorrow will bring another day, another chance to watch, another opportunity to learn. But for now, let the darkness hold them, let the quiet continue. Let the ancient patterns flow forward undisturbed. The giraffe doesn't need our attention to exist, but it enriches us to give it anyway, to understand, to appreciate, to recognize what we're seeing when we see these animals, not just tall creatures with spots, but living solutions to impossible challenges, natural wonders that walk the earth alongside us. Reminders that the world contains more complexity, more beauty, more quiet brilliance than we usually take time to notice. Rest now. The giraffes will still be there tomorrow, still feeding, still moving, still existing in their patient, gentle way. The savanna will hold them, the patterns will continue. And somewhere in that continuing, in that steady rhythm of life maintaining itself, we find something that settles us, calms us, reminds us that some things endure simply by being what they are: simple, steady, present. Good night to the giraffes. Good night to the savannah. Good night to the patterns that hold everything together in quiet harmony beneath the endless stars.